All right, so this is the vocab word on your notes outline, and you need to pause your video and write this down. So the formula for this is the change in the dependent variable over the change in the independent variable. So this very much crosses over into science. And when we're talking about dependent variable, we're talking about the variable that goes with y. So you want to add that on there. And then when we're talking about independent variable, we're talking about the variable that goes with x. Okay, so starting off, what we're going to look at is determining whether or not the rates of change are constant or variable. So first, let's look at what those words mean. What does constant mean when you say something is constant? Stays the same thing every time. Okay, if it's variable, what do you think that would mean? It changes, it's different, it's not the same every time. Okay, so we're going to look at whether or not the rate of change is constant or is it variable. So look at your x values. That's the first thing you need to do. Are your x values going in order?
No.
Or are they skipping? Skipping. So what we're going to do is we are going to create another XY chart without skipping. So I'm going to put in what information that I have. So like I know that 0 goes with 0, 1 goes with 4. I skip 2, so I'm going to put a 2 right there, and I don't know what goes with 2. But I know that 3 and 8 go together. I didn't have 4 or 5, but 6 goes with 8. And then I don't have a 7, so I'm going to put that in there. And then 8 goes with the number 6. So basically, I'm filling in the holes of what I didn't have on my x values, and I'm putting them in my new XY chart and leaving spaces because I don't know what those values are. Okay, so I want you to look at your y values, and I want you to see if you could fill in the missing parts. Like, is there a pattern? Could you fill anything in?
No.
What kind of clues you into the fact that there is not a pattern?
Because it repeats the same number twice.
It repeats 8. So I don't really know of any patterns that I've ever seen that are going to repeat numbers like that. So this would be a variable rate of change. A variable rate of change. Okay, we're going to do this again. So look at your x values. Do you have any skipping?
Yes.
Yes, so we're going to recreate our XY chart and fill in the missing numbers. So I skip 2, skip 3, and then go to 4. Okay, so I want you guys to look at your pattern and see if you can find one. Look at the y values. Do you have a pattern?
Mm-hmm.
Okay, what is the pattern? It's adding 1 every time. So here would be a 3, a 4, and a 6. Okay, so this would be considered a constant. So it's adding 1. So this would be a constant rate of change. Okay, number 3, same process. So I'm going to make my XY chart. then I skipped over 2, and I skipped over 4. Okay, it's adding 2, so it's going up by 2s. So this would be 4, 8, 12, and 14. All right, so adding 2, so is this constant or variable?
Constant.
Constant,
Is this what the homework's gonna be too?
part of it, yeah. Okay, I want you guys to try to do number 4, so you'll need to pause your video and just go through number 4. All right, so if I extend my XY chart, and I could probably stop at this point because what happens? It repeated, so this would be a variable rate of change. Okay, all right, so we have a couple word problems to go over and then we are done. So, the equation D equals 0.2s represents the approximate distance in miles of a thunderstorm when s seconds pass between a flash of lightning and the sound of thunder. About how far is the thunderstorm from each student listed in the table? So s is for seconds, and we have 5, 9, 4, 11, and 8. So, and we are going to calculate how far the storm would be from them. So we have to take 0.2 times their seconds. So 0.2 times 5.
1.
Yeah, 1. And then, so that would equal, our coordinate would be 5, 1. And then you're gonna go down through the chart. So 0.2 times n, and 9, not n,
1.8.
is 1.8. So my coordinate would be 9, 1.8. 0.2 times 4, 0.8. So that's 4, 0.8. And then finish up 11 and 8. Okay, so what do you get for 0.2 times 11?
2.2.
2.2, so the coordinate would be 11, 2.2, and then 0.2 times 8,
1.6.
1.6. Okay, so we need to graph this. So our seconds are gonna go along our x-axis because that's what we plugged in for our independent variable. And then this would be the distance. Okay, so our distance goes as high as 2.2. And every one of them would be a multiple of 0.2. So probably the easiest way to handle your y-axis as far as labeling would be like up by 0.2, in my opinion. So like each box would represent 0.2. So that would be 0.4, 0.8, 1. And you're just gonna have to go a little bit off the chart to get to 2.2, which would be right there. So then you're gonna go through and plot your points. And I would just have each of these going up by 1. So like this would be 5 seconds right here. Okay, so then I would draw a line through this. Is this linear? Yes, it is going in a straight line. So this would be linear. Okay, we're gonna take a look at number 6. So on number 6, a lift on a ski slope rises according to the equation A equals 130 T plus 6,250. Okay. A is the altitude in feet, and T is the number of minutes that a skier has been on the lift. What is the altitude of each person after they've been on the lift for the times listed? Okay, so what would a ski lift be running on? Like, what would be running a ski lift?
People?
Well, there's probably an operator, yeah, but what's gonna get that machine going? A motor, right? So it's gonna be, would a ski lift, when you get into the individual cars, do they have to be going at the same speed?
Yeah.
What would happen if they weren't on the same speed? Think of like a roller coaster.
You'd hit each other.
You would hit each other if it wasn't the same speed. So these would have to be going at a constant speed, or you would have different cars hitting each other on the ski lift. What do you think this number right here is representing in this scenario?
It was.
Like, what do you think this altitude represents in this scenario? It's altitude.
How high above sea level?
How high above the sea level in feet, but this would be the point that you would be getting on the ski lift. Like, you're getting on the ski lift at 6,250
So that's the
feet.
start.
That's the starting point, yeah. And we're gonna calculate the ending, the number of feet they are at that time. So what we need to do is take each one of these numbers and plug them in for T. So 130 times 4 plus 6,250.
6,670.
Okay, and then 130 times 3 plus 6,250.
6,670.
6,400.
6,350.
So now what we're gonna do is graph this. Since all of our values are in the 6,000s, I would recommend we go up by either 500 or 1,000.
Correct.
So, so we probably could go up by 1,000, would be a good idea. So then we need to graph all of our points. So this is, on the x-axis, that's representing time. And then the y-axis is representing altitude. Okay, so if we were to draw a line. And our starting point would be like roughly right here. So is this linear? Yes, this is linear. Okay, so I'll come back to that if I need to, but here's your assignment. So this is number 2 out of this homework. So I want to point out something really quickly so there's no reason to be confused. Here are the problems that you have to graph. So you need to graph number 6, 15, 16, 18, 25, 26, 27, 29, and 30. So also I want to point out to you that this type of graph paper has 4 quadrants like this. It's not like a traditional science type graph paper like we were just using. So you have 2 options when you're graphing most of these. So option 1 would be to only graph in this quadrant right here, and to then use this part like as your y-axis and this part as your x-axis. You could do it like that. Or your second option would be to ignore the middle, the origin right there, and just pretend that this is one big graph right here. And this is your y-axis and this is your x-axis. And then you would just graph using this entire space. I would personally recommend option 2 because you have more room to graph then. And you just kind of ignore the x and y axis in the middle and you just use this whole entire thing. Okay?
I would recommend that.
Yes.
Right, you should have done it.
What?